Hello, welcome back to Physics by Hand. My name is Eric, and today we're going to talk about unit prefixes. So let's start off by putting that into our notebook as page number 1. Unit prefixes. All right, and then we'll go to page number 1, and we will say unit prefixes. So what is a unit prefix? So this gives us a sense of scale when we're talking about length or mass or time by being able to make it very big and very small and not say, 10 to the 27 over and over again or 10 to the negative 15 over and over again. So you're probably familiar with prefixes like kilo or centi or micro or milli or nano, for instance, in nanotechnology. So what we're going to do is we're going to just lay out all the different prefixes there are in the SI system. So we're going to start by saying what the name is, what the symbol is, what we're multiplying it by, and we're going to have that in terms of an exponential and in terms of a decimal. So let's start by counting down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we're going to have this as our base unit. There's not going to be a symbol for that. And that's going to have a scaling of 10 to the 0, which is just the same as 1. Now, if we want to go down, there's deci, which is D. So that is 0.1. So that is 10 to the negative 1 in exponential form and 0.1 in decimal. So if we want to go up, we can do deca. Also not terribly often used. It's abbreviated DA. That's 10 to the plus 1 or 10. Deci you really only see in something like a decibel. We'll talk about what decibels are a little bit later. Make sure I got all my ones nice and proper so that nobody mistakes them for L's or I's or anything like that. Try to keep things tidy. Okay, so next up from deca is hecto with an H. So that is 10 to the plus 2, which is the same as 100. So hecto, you're most likely to hear about in terms of hectacres, which is 100 metric acres. But that's a thing that we'll get to when we're talking about compound units. So above hecto is kilo, which is K. Everybody's hopefully familiar with kilograms. That's 10 to the 3. So there's 1,000 grams in a kilogram. And above kilo is mega. And that's going to be with a capital M. So that is 10 to the plus 6. So that is going to be 1, 2, 3, 4, 5, 6. So you'll notice we've got 10 to the 6, there's 6 zeros. 10 to the 3, there's 3 zeros. 10 to the 2, there's 2 zeros. 10 to the 1, there's 1 zero. Past the decimal point. 10 to the 0, there's no zeros past the decimal point to the left. So above mega, we've got giga. You might have gigahertz or gigabytes. So that's with a capital G. So that's 10 to the plus 9. And that is going to be 1 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And a decimal point. So above giga is tera. If you've got a large hard drive, it might have a terabyte. in it. So that's 10 to the plus 12. And I'll tidy up my ones here because I'm not always super consistent about doing my ones, but I should be. So I will make mistakes. And if you catch them, please mention them in the comments. All right, so above tera is peta. It's a capital P. 10 to the plus 15. And I'm going to stop writing out all those zeros now because that's starting to get to be a lot of zeros. Above peta is exa with an E, capital E. That is 10 to the positive 18. And then we've got zeta, Z-E-T-T-A. That's a capital Z. I like to put a little dash there just so that it doesn't get confusing. And I think it looks snazzy. 10 to the 21. Yata. There's a whole yada stuff in a yada, capital Y. It's 10 to the plus 24. Now we've got Rona, capital R. 10 to the 27. 10 to the 27 is a lot of stuff. And then we've got Quetta. That's a capital Q. Possibly saying that incorrectly, but that's all right. 10 to the 30. So when would you use these sorts of huge numbers? Well, yada is going to be on the order of the number of atoms, say, in a small volume of water. So these are generally pretty big numbers. And we've got other units for talking about the difference between atoms and molecules that predate these. Okay, so let's go down in terms of size. So below deci is centa. So like centimeter, that's just C. And that is 10 to the minus 2. So that is 0.01 or 1%. We'll call this or 10% or 100%. Below centi is milli. That's with a lowercase m. That is 10 to the minus 3, 0.001 or 0.1%. Below milli is micro. So this will be either a capital or a lowercase mu, which is Greek, or sometimes it'll be abbreviated as a U on computer systems. That's 10 to the minus 6. So 0.000001 or 1 part per million. Below that, we've got nano, which is N. So if you talk about nanometers or nanotechnology, we've got 10 to the negative 9 here. That's 0.000000001. So that's 1 part per billion. Below that is pico with a P. 10 to the minus 9. It's also a street in some California cities. That is 10 to the minus 12. And I'm not going to write that out, but that is 1 part per trillion. So that's pretty tiny. Below pico is femto. That's with an F. That is 10 to the negative 15. Below femto is atto with an A. That is 10 to the minus 18. Below atto is zepto with a lowercase z or z. depending on if you're in British English or an American English speaking area. I will have a tendency to mix and match there. Yakto, that's a Y, and that is 10 to the negative 24. Then we've got Ronto, R-O-N-T-O, lowercase r, that is 10 to the negative 27. And then we've got Quento, Q-U-E, Quecto, lowercase q, 10 to the minus 30. So this is very, very, very small. This is very, very, very big. So why write this out instead of just, going to Wikipedia or downloading a PDF? So the whole premise of this series is that the process of writing things down by hand is going to help you remember things, and it's going to help you hopefully ask questions about, well, why is that, or where does that show up? So when you're writing these things down, if you think of other stuff that comes up, certainly make a note of it. And if it helps you remember, that's fantastic. Okay, that's it for now. Talk to you later. Bye.